Today we will be talking about the approaches or principles which are used for designing the components. So you must have heard the word ergonomic design, like the chair is ergonomically designed, or the bed, or any other the product or the component to be used by the human being is designed considering the principles of ergonomics, considering the anthropometric data of the users. So if that is done in developing the design, then we say that the product or the component is ergonomically designed. Okay, so initially we will be looking at the various principles which are used in developing the ergonomic designs, and thereafter we will see like the how the temperature related conditions affect the human body and the performance of the worker during the work. Okay, so these are the two aspects about which we will be talking. So we'll be starting this lecture with the various steps which are used in development of the ergonomic design. Okay, so you can say design using ergonomic principles. Okay, so, or you can say simple ergonomic design. So in ergonomic design we have to keep in mind the anthropometric aspects related with the user. Anthropometric aspects means what are the various dimensions, various capabilities, various the possibilities associated with the body parts who will be using the particular product or the component. So anthropometric aspects are kept in mind while developing the design of a product. Then we call it as a ergonomically designed component or the product or the device. Okay, so the first thing here in development of such kind of the design, there are certain steps which are followed. So is first step here is to see like which dimension, which anthropometric aspect of the body is important for the design of a particular component. Like say the chain of the watch, a wrist watch, so maybe the diameter of the wrist, similarly the goggle head width for the goggles, then for designing the location of the lever, okay, or the gear lever, so how far it will be located or how close it will be located. So those will be based on the different the kind of aspects. So first determine or identify the anthropometric aspect, or you can say the body dimension relevant for design. Okay, like the design location of the water tap in public, or the design of the various taps in the bathroom. These two designs may be significantly different. If it is user is fixed, then he can choose the things as per his own convenience. If the users can be anybody, like in public places, then the design aspect will be different. Okay, so determine the anthropometric aspect or the body dimension relevant for design of that particular product. Okay, then this to a great extent, how it will be determined, how this anthropometric data or the dimension will be determined, that will depend on, like, define who will be the user, define the users or the population of the particular product which is being designed. Say it is for army man having very good build, then it is for, say, school children, or it is, say, for KG students. So this group itself will define the kind of categories, what can be the anthropometric aspects related with the user group. Define the user group for whom a particular product is to be designed. Okay, and this will primarily help in identifying the range of the body dimensions. It is close or it is very wide. Okay, range of the body dimension. It is, say, height will be 3 feet, or it will be 5.5 feet, or it will be, so average height, based on the average height or average body dimension of the user, you can take a call like which kind of the body dimension, what will be the on an average the body dimension or the range of the body dimension which can be used for the design purpose. Okay, so first is the identification of the type of the anthropometric aspect which is important, then who will be the user. Based on this you determine, like, use the or select the suitable body dimension data from the database based on the users. Okay, so define the user or the population for whom the product is to be designed. The third aspect is based on which principle the product will be designed. So identify the principle to be used for design. Okay, so this will depend upon, like, what is the population which is to be covered in a design, depending upon the nature or characteristic of the product. Like the bench being designed for the bench to be placed in a park, in a public place, or the bench to be designed for the KG students, or bench to be designed for adult users. So the dimensions can vary significantly depending upon the user groups. So also you have to see if it is for the general public, if it is for those who are having the extreme anthropometric aspects, or it is for a kind of anybody can be user, and so the design a product in such a way that every user is more comfortable with the design. So considering there are three aspects, there are three principles which are used in design, in ergonomic design. One is, like, say, for whom the design is being developed. So the principle of extremes, where the design is developed for those having the extreme anthropometric data, anthropometric features or anthropometric dimensions, like height is 7 feet. So those if the product is designed for those who are having the height of 7 feet, means those who are having less than 7 feet will always be accommodated. Similarly, something is being designed for minimum dimension of 2 feet height, person having the height of minimum 2 feet, which means those who are having the height greater than 2 feet will always be able to use it. So that is about the design for extreme. Basically, the design for extreme means those who are having the extreme anthropometric data. Okay, and when you don't have any specific user group, then we use the principle of design for averages. There is no specific set of user either on the higher side or in the lower side. User can be anybody. Like the tap is to be tap height in the public place, or like I already gave the example in the example of the bench height in the park, in a public place. Okay, so the design, the third one, where you feel that user can be of having the height of 5 feet, user can be of a height 6 feet also, or 5.5 feet also, or 6.5 feet also. So you consider that, come up with such kind of the products which can be used by the users having very wide range of the anthropometric dimensions, but at the same time the convenience or comfort is also there when the users of the very wide anthropometric dimensions are using the same product. So we use, in that case, we use the principle of you can say adjustable range. So we use the concept of design for adjustable range. Okay, this is the third principle. Then the fourth step is what you want to cover, like what percentage of the population you want to cover in the design features, so that and based on that the dimensional aspects or the design of the product is finalized. So decide the percentage of population to be accommodated in the design features, so this is the another one where we want to cover entire range of the people, like those who are having the height from say 2 to 7 feet. This is one. Or you want to cover the people of having 5 to 6.5 feet. So if you see the kind of percentage of the people who are there of 2 to 5 or greater than 6.5 to 7, the very few people here and very few people here, but most of the people are in this band. Okay, so here you may find 90% of the people are of this band, 5% here and 5% here. So it may not be very useful to come out with those design features with the extreme design features or very wide range of the design features, which will simply be increasing the cost rather than increasing the benefits to the number of users. So number of users at the end extremes you may find very less, while most of the things will be segregated somewhere in between. So we have to take a call if the design will be serving the purpose for the 90% people or 95% of the people or 99% of the people. It is not advisable to come out with the designs which will serve the entire range of the anthropometric aspects, because it will be the products and the components will be too costly, and the number of people who will be benefited with such kind of the designs may not be many, there will be very few. So why to unnecessarily push the cost just to accommodate the 100% of the population? Although this is unethical in the sense that you are leaving intentionally those who are with the extreme anthropometric aspects, but it is a kind of combination of the cost and the number of users. You have to maintain the lower cost and you have to have the higher dimensions, a higher number of the users. So this is a very important decision, like what is the kind of percentage of the population that we want to cover in or include in the design feature. Then the fifth point related with this is get the anthropometric data. If it is not there, just develop this, and if it is already available, then get the anthropometric data. Okay, data this from the record. So the data is available in a different forms, like say the what is the dimension if the only 5% of the population is to be covered, if the 50% of the population is to be covered, or if the 95% of the population or 99% of the population is to be covered. Like say, so for a particular dimension you may say particular dimension for 5% is it 60, for say for 50% it is 68, and for 95% it is 72, and it is say it is 77, like this. So these are the say the anthropometric aspects. It is say it may be in height or centimeter or mm, you can consider anything. So if we take a call for having an adjustable range, then adjustable range feature should allow from 90 to 95% of the population will be able to use, not those below this, not above higher this. Okay, so anthropometric data with the target percentage of the population which is to be covered, also termed as a percentile of the population or the target user group to be covered. Based on that, we select the suitable data. I'll show you the table in the using the PPT, and after this using this anthropometric data, come out with the design of the product, maybe height of the chair, height of the seat, or handle width, wheel dimensions. So as per that kind of product which is to be designed, suitable anthropometric data is collected and used for the design purpose. So on the principles I will come little later. Let me talk about this last point related with the steps in design, ergonomic design of the product, that is add allowances if any as per the case, like the thickness of the shocks is to be considered in the shoe design. Okay, and similarly in case of the design of the clothings, the thickness of the other cloths need to be considered. So add the allowances suitably for other aspects related with the users. Okay, these are the steps I have just described. Determine the important relevant body dimension to be used in design. Define the population who will be using the product, like KG children or the army men or the housewife. So depending upon the kind of users, accordingly this user population or the target user group, you will get the like a kind of dimension to be used in the design. Choose the suitable principle for ergonomic design, like design for extreme, design for adjustable range, and design for averages. Okay, and other aspects like decide the percentage of the population need to be covered in the design, 90, 95 or 99%. Get the anthropometric data of the target population from the record for the different kind of the percentage of the people to be covered. So this data I will show you in the next slide, and add the suitable allowances if required, like thickness of the shocks and cloths in design of the relevant item. Okay, so the anthropometric data, just for an example, can be developed in different ways for the different purposes. Just for an example, if the anthropometric data for a particular user group, say identified in terms of stretcher height, like say from the top to the bottom, then eye height, like say from the bottom to the eyes, then the shoulder height, then chest height, the chest depth, then elbow height. So all these are from the the bottom, and these dimensions are given, say, here for the different users. So here if you see that this dimension is different for the different percentage of the people if they are covered, like 5th percentile, 50th percentile and 95th percentile. Okay, so if something is to be designed for an adjustable range, then this is the normally used the range of the dimension to be covered. Okay, for male and female likewise. Okay, if it is for 50th percent, like if it is just for averages, then this will be the kind of dimension to be used. So if something is to be designed for averages, the things to be used in public domain, like the benches in park or the tap location or tap height in the public place, then we use this dimension. Okay, if it is about the extremes where both higher and the lower dimensions need to be covered, need to be considered for coming out with the design so that every user group can use it, we consider the 5th and 95th. But this is the most commonly used the percentile anthropometric aspect, where 5th to 95th percentile of the anthropometric data is used. Okay, similarly for eye height, shoulder height, elbow height, knuckle height, everything is the suitable data is collected from the record, and then it is used. If it is not there, you can also come up and develop it. So these are the other dimensions, like height in sitting position for 5th, 50th and 95th of the percentile. So the different body other dimensions are given as per the need of the design. These can be suitably used, or if these are not available, these can be suitably developed. The point here is, if something is for extreme conditions, these need to be considered. Something is for adjustable range, then these also need to be considered, both 5th and 95th percentile data. And if something is to be used for averages, then 50th percentile, the data anthropometric data corresponding to the 50th percentile is used. Okay, so this is about the anthropometric data which will be available. If not available, then it has to be developed. Like, say, the first is about the design for extremes. Okay, so when the design for extreme means design for the people having the extreme anthropometric aspects, anthropometric features. Okay, anthropometric features. So when it is designed for extreme conditions, means those who are having the lesser the dimensions or the more dimensions as per the case, all those will be able to use, say, the design of the physical systems to those with the extreme, high or the low anthropometric characteristics. This is the basis for this. So, for example, designing the height of the door may be based on to accommodate the tall individuals, so that either 99 or 95 percentile of the people are covered. So it may be like, say, 7 feet or 7.5 feet or 6.5 feet as per the case. So depending upon the kind of the percentile of the people that you want to cover, so select the anthropometric data accordingly to come out with height of the door. So those who are having the height lesser than, so this is the case when we could have come up with the door height of 5.5 feet or 6 feet, 6.5 feet or 7 feet. So here you may see, if it is 5 feet, the anthropometric data, the percentile of the people covered is just 70. If it is 6 feet, it may be 90, or it is 6.5 feet, 95%. And here you will see the, say, 99% for the 7 feet. So depending upon the percentile of the people that need to be covered, we select the suitable anthropometric dimensions for the suitable design purpose. Okay, those who are having the lesser dimensions will already able to use this. Such height would also accommodate the people with the smaller height. Okay, And you know, in case of the doors, if it is the single or the double, the different dimensional features, but it is more about the height set in case of the design for extremes. So here what is the logic which is used? The minimum dimension or feature of the product, it is based on the upper percentile value. Okay, minimum it will be 6.5 or 7 or 5.5 or 6. That will be based on the kind of the percentile of the people that we want to cover. So the anthropometric data is used accordingly. Similarly, the maximum dimension or feature of product is based on the, this is the minimum side, and on the maximum side, like maximum at what distance the gear lever can be located. Okay, the maximum dimension at which gear lever can be located. So how far maximum it can be located? So here, based on the lower percentile value of anthropometric data of first, fifth and 95th 10th percentile data is considered for the maximum dimension. So for minimum we consider the upper percentile value, and for maximum dimension we consider the lower percentile value of the anthropometric data. So it is very common to use the 95th to the 5th percentile value of the anthropometric data for design purpose. So this is the another example. Here you see this handle of the door, door lock you can say, this can be located at the different height depending upon the users. So if it is in public place, then it has to be there in such a way that all users can use it, while if it is for the specific user, then it will be placed as per the anthropometric dimensions of the user. Okay, similarly, where these controls will be placed, that will decide. So how far these can be located from the driver, that will depend upon. So maximum distance, maximum dimension here will be based on the lower percentile value. So at least 1% of the people or 5% of the people should be able to reach there. That will be the maximum dimension. And though if it is located the closer to this, then all higher percentile of the people will be able to use it in any case. So if it is closer to, this is the maximum dimension, if it is closer to, then everybody will be able to use it. So if we see how the requirement changes with the kind of population to be covered, and how the things change with the dimensions of the product. So here you see the design parameter value corresponding to 5th to 95th percentile value is considered to be most feasible, because if we see here, you see say from 5 percentile to the 95 percentile, this is the percentile of the population covered. Okay, population percentage of the population covered is say. So this, from this to this, if you see with the increase of the design parameter, there is a linear relationship. So while for this large range there is just 5%. Okay, similarly on the higher side, for this higher, for this much value there is just 5%, while the similar this there is a increasing the anthropometric dimensions, increasing the design feature will be increasing the population being covered linearly. So there is actually a kind of direct relation. On the other hand, there is a significant increase in the dimensional requirement for a very limited users, 5% users or say 1% users at the very extremes. So it is as the design for 100 percentile would push the trade-off cost too high as compared to the additional benefits. So means we are not much benefited with the increase in the dimensions to cover the entire range of the population, especially at the extreme ends. So this is not included. So what we do, we try to develop the design for extremes such that 95 to 95th percentile of the population is covered in the design. Okay, now this is about the design for averages. It is used when there is no fixed user group. भैया क्लास में हूं मैं, 11 बजे के बाद मिलना, ठीक है? हाँ ठीक है. It is used when users do not belong to a particular group or category. Means it's a kind of there is no fixed user. Even the children can use, adults can use, ladies can use, so anybody can use. So when there is no fixed user, at least in this case, so in this case also, like say this is a special case, but the normal bathroom fittings, or if something is to be done for the public places, in that case there is no fixed user. So in such situations, the height is kept in such a way, or any dimensional feature of the product which is being designed is kept in such a way that it is less uncomfortable for most of the people, and that is about the design for averages. It is not an optimum design, but it will cause the minimum design for most of the population. It will cause the minimum discomfort during the use when the entire population is considered. Okay, so additional height in such cases where something is to be designed for public places, height is kept or the dimension is kept in such a way that it will be less uncomfortable for most of the people than when the design is done for extreme cases. So we don't do this design for extreme cases. And similarly, things which are designed for public places where there is no fixed user, we also don't use the design for adjustable range. Okay, so here the design for adjustable range, that's what we get in for users where so for the products or for the cases where users of varying anthropometric features will be using the product. So here this will be pushing the cost now on the higher side. You are not considering the user of a particular anthropometric aspect, but you are considering the anthropometric aspect in such a way that you can make a product so that a wide range of the users can use the same. Okay, with the minimum possible discomfort. Okay, so the design using the principle of adjustable range is used when the design itself incorporates the anthropometric features for a very wide range of the user group. Okay, so adjustable range is commonly designed for 5th to 95th percentile of the range. Like say the chair height adjustment, or so here if you see the chair height adjustment is how much, you can see this is the kind of so here one can adjust this height of the chair. Computer chairs are mostly of the adjustable height range because there can be any user, or there and in the different situations these can be used in different ways. Okay, so they are provided with the adjustable height range. Similarly, to make to avoid the sitting of the workers for longer periods, the systems are designed in such a way that they can be they allow the use in both standing and the sitting postures. So the discomfort related with the continuous sitting for longer periods can be avoided. So but you cannot cover the entire range of the population also. That will be clear in the next example. Here you see this is the case, like say here adjustable range, you have the feature, design feature such that the people of the any height, population of any height can use these kind of the products, and there is no fixed height, rather the adjustable height of the product in bathroom fittings. Okay, so how the adjustable range is selected. Now you adjustable range, like say if the children of 10 years age or adult of 30 years age, both may require the different kind of the heights for the bicycle or for chairs. So but you cannot have it for the entire range, because the requirement for adjustable range will be very high, and this will increase the cost of product significantly. So what we do, we cover the 5 to 95% of percentage of the population. Adjustable range is selected in such a way that it covers the 5 to 95% of the population, because at the extremes it will simply increase the cost without increasing the number of people who will be benefited with the increase of dimensions. So that's what you see. The amount of adjustment required to accommodate the extreme conditions like above 95 or below 5th percentile is not found in proportion to the additional number of people who will be benefited. This is what I have already said. So for example, like seat adjustability requirement in bicycles, see 5th to 95 percentile people can be covered if the adjustable range of 10 centimeter is given. Okay, this adjustable range of the 10 centimeter is given, then it will cover the 5th to 95 percentile of the range of the population, right? If we have to cover the 1st to 95th 99 percentile of the range of the population, then this dimension comes out to be of 15 centimeter, and if you want to cover the 100 percentile of the range, this range comes out to be, so if you see this, for this 90% of the people you need just 10 centimeter dimension of the seat adjustable range, but for this additional 8% of the population you need 5 additional centimeters, and for one more additional percentage you need further 11.5 adjustable height range requirement. So these will be pushing the cost significantly, and that's why in the design, even for adjustable range, we cover the 5th to 95th percentile of the range. Okay, now this is the next topic. So that's how we covered the way by which the ergonomic design of the different products is developed. Here we haven't talked about, like, there is the diameter of the pen we use. So similarly, the bed height or anything which is to be designed for the human being, these principles and the anthropometric aspects are kept in coming out with the design. Okay, so now next is about this is about the physiological aspect related with the ergonomics, where we try to see how the working conditions affect the workers and the human being during the work. So the one is like during the work, their energy is consumed, at the same time heat is generated. So heat generated due to the work, one, and heat generated due to the metabolic activity of the human body. So there are the two heat sources, one due to the work and another is due to the metabolic activities. Okay, so whatever heat is being generated, if the body is not able to release the heat, dissipate the heat to the surrounding, then body temperature will start rising, and the body temperature in general for the healthy man is constant, that is around 37 degrees centigrade, and if the temperature keeps on increasing, it will bring in lot of issues related with the health to the human body. So how does the human body responds to the working conditions as far as the temperature is concerned? Temperature, too high temperature or too low temperature, both will be adversely affecting the output and the performance of the worker. So as far as the working conditions are concerned, the first is the heat exchange process of the human body in working conditions. Second is the light or illumination required for the different activities, and third is the vibration and its effect on the performance of the worker. So we'll start with the heat exchange from the human body. Okay, so heat exchange process of the human body, heat is generated So this is just a figure to show that when the heat is generated due to the metabolic activity or some kind of the physical activity, this heat is dissipated. So the work will be done by the workers in some kind of the environment. Now this environment can be at 45 degree or can be 5 degree, while the body temperature is 37 degree. So you see, there is always a kind of difference of temperature if it is unfavorable condition. So when the temperature is too high, obviously the heat will be supplied to the body from the environment, okay, from the surroundings, while when the temperature is low, heat will be dissipated, okay. So there are certain ways in which there are certain modes of the heat dissipation or heat transfer or heat exchange, in which heat can be transferred to the body or heat can be transferred away from the body, okay. So the typical example of this is like convection and the radiation in both the cases. Let's say when the temperature outside is high, then the radiation from the sun, like this, or by the radiation heat will be transferred. Then if the temperature is high and the sweating from the body is taking place, then evaporation will be leading to the heat loss to the surroundings through the convection. Similarly, the hot air passing through the human body will be transferring the heat to the human body. So there are different ways through which the heat is heat exchange between the human body and the surrounding takes place. One is radiation, second is convection, and third is conduction, and this is evaporation. So basically the heat loss through the convection, evaporation and the radiation. The role of the conduction is very limited. These are the three main sources. Evaporation, convection and radiation are the main sources of the heat exchange, main modes of the heat exchange during the work. So during the respiratory activities causes the heat loss as well as gain through both convection and evaporation. So here an adult generates the heat due to the metabolic activity even at rest at this rate, 1 to 1.5 kilocalorie per minute, okay. But when the worker is working or doing the heavy work, he can generate heat at this rate. So the heat is getting accumulated. This heat must be dissipated, otherwise the temperature of the human body will increase significantly, and that can affect the human being significantly, okay, and his performance may be deteriorated and health may also be adversely affected. So the body temperature, so the heat is generated but the body temperature is constant. For a healthy man, body temperature is constant, so whatever heat is generated must be dissipated. So heat exchange from the body to the environment or from the environment to the body takes place to maintain the equilibrium so that the body temperature remains constant. So because you can have the very hostile, harsh, low temperature conditions or very high temperature conditions. In both the cases, there will be some kind of exchange of the heat from the body to the surrounding or from surrounding to the body, so that the body temperature is maintained. If it is not so, then the body will start behaving in very erratic way, in undesirable way, okay. And if there is no heat loss while heat is being generated by due to the work or due to the metabolic activity, then sweating glands will activate and they will cause sweating. Sweating will lead to the evaporation and the body temperature will come down. So there are different aspects related with this. So here what it is basically, when you have the hot surrounding conditions, the surrounding conditions are hot or ambient conditions are hot, So this is you can say skin, right, through which close to that blood circulation is taking place. So heat transfer from the blood through the skin. Okay. So when the outside temperature conditions are hot, you see this upper section. So the heat is transferred from outside to the skin by radiation. Heat is transferred by convection to the outside, or it is also received by the body. So convection plays a role in dissipating as well as accepting, means it is receiving as well as dissipating the heat to the surrounding. So radiation, heat is basically is being received by the body. Heat is received and transferred away by convection, and mainly the heat loss from the body takes place by the evaporation when the conditions are hot. So this height of these signs indicates the relative importance or relative degree of the heat transfer by these modes. Say for radiation, for convection, outing, heat being received by radiation, heat is being transferred away by the body by convection, and heat is being received by convection. Similarly, heat loss taking place by evaporation. So evaporation plays a major factor in loss of the heat from the body, which helps in maintaining the body temperature. Okay. Now the second section is this, okay, where comfort conditions. In comfort condition, mainly the heat loss is there by radiation, okay, to the surrounding, and heat loss is there by convection, and heat loss is there by evaporation. So radiation is the main source of the heat loss. So in comfort condition, these are the three ways by which the heat exchange between the body and the surrounding will be taking place. When the conditions are cold, the heat loss is there primarily by radiation, then little less by convection, and further less by evaporation, because in cold condition evaporation possibilities are very negligible. So length of these signs corresponding to the modes of the heat transfer indicates their relative importance and the relative degree of the heat exchange from the body skin to the surrounding environment. Okay. So the radiation and the convection, these two play a major role in the cold conditions. Okay, so in cold conditions, efforts are made to reduce these two losses by giving the proper clothing. Okay. Similarly, in hot conditions, the people need to be protected so that the exposure to the hot condition is avoided. So heat goes to or from the body primarily by the different modes of heat transfer by convection, radiation, and evaporation, and the relative amount of the heat exchange by these modes depend on the environment, like the conditions, temperature conditions,